Hi everyone. Initially, I didn't plan to make a separate summary video for chapter 3, but as I reviewed the material, I realized that a summary video is absolutely necessary. In the last three videos, we learned a lot of individual rules, but in this video, we are going to use a complete real-world example to see how all these rules fit together perfectly. This will help you practice and cement everything we have learned so far. Before we jump into our slides, let's take a very quick at the final code of listing 3-7, which is SetupTeardownIncluder.java. Look at how clean, readable, and beautifully split this file is. Every single method feels short, easy on the eyes. Now let's go directly to our slides to analyze exactly how Uncle Bob used our chapter 3 principles to build this masterpiece. The absolute first rule of function is that they must be small. Look at this active examples on your screen. The method is TestPage is exactly one line. The method updatePageContent is also one line mode. There are zero nested loops and zero hidden complexities here. Call this the sparkle standard. Because these functions are so tiny, they are perfectly transparent. You don't even need to write comments because the code explains itself instantly. Next, a function must be do exactly one thing. Let's test include setup and tear down pages here. To include setup and tear down pages, we include setup pages, include the main content, include tear down pages, and then update the content. All four of these steps operate at the exact same level of detail. Look at how include setup pages delegates its internal choices to its own separate method. This strict delegation protects the parent function from multitasking or doing too much work. One level of abstraction per function. To keep a function clean, we must never mix different levels of abstraction. Look at the active construct between these two methods. Render is a high-level orchestration method. It only coordinates business concepts and doesn't touch strings or buffers. Now look at buildIncludeDirective. This is a low-level method that deals purely with raw string append details. Because a high level stays high and low level stays low, the reader never experiences an unexpected cognitive break. Now let's look at the absolute golden rule of chapter 3, the step-down rule. This rule says your code must read like a top-down narrative, descending one step of detail at a time. Let's trace every single method on this slide to see how it works. It starts at the very top with the render method. This is our high-level headline. It simply coordinates the story. If it's a test page, includes setup and tear down pages, no complex logic, no string buffers. Right below it, we step down into include setup and tear down pages. This is our orchestrator. It reads exactly like a TO paragraph. To include these pages, we include setup pages, include page content, include tear downs and updates. All steps are at the same conceptual level. And next, we descend further into include setup pages. It naturally branches the story if it's a suite, include the suite setup, otherwise just include the regular setup. It doesn't do the work itself. Uh, it immediately delegates to its child methods, include suite setup page and include setup page. Moving down, we hit the mid-level logic with the include method. Here. This acts as our bridge. It safely finds the inherited page, gets its path name, and passes it forward. Finally, we hit the bottom of the stairs, buildIncludeDirective. We are no longer talking about business concepts. We are looking at raw string appends, exclamation points, and lines. Because high level stays at the top and low level stays at the bottom, your reader never gets lost. This elegant cascade is the ultimate secret to mastering clean functions. Now let's drop other rules. Let's recall Ward Cunningham's famous principle. You are working on clean code, which each routine turns out to be pretty much what you expected. Half the battle is the choosing descriptive names. Look at this beautiful, consistent naming pattern. Include setup and teardown pages. Include setup pages. Include suite setup page. This shared phraseology creates a predictable story. Because the names are so explicit, you naturally expect to find and include teardown pages method, and you find it exactly where it belongs. As we learned in our previous video, function arguments take a lot of community power to train. In listing 3-8, look at how aggressively Uncle Bob tries to minimize parameters. Most of our private methods, like include setup pages, are completely nihilistic, zero arguments, meaning they take exactly zero arguments. By saving our state data into class instance variables, our functions remain clean. We only use monadic or dyadic forms for universal low-level helpers like buildIncludeDirective, keeping the primary business code completely free of parameter clutter. Common monadic forms. When SetupTeardownIncluder does use a single argument, it follows our predictable patterns perfectly. isTestPage is a clean collection query that returns a boolean. Get name for a page is a clean transformation that processes an input and returns a string. Most importantly, notice what is completely missing. There are absolute zero output argument traps. We never see confusing structures like void include setup page into string buffer page text. Transformations always return a clear value instead of silently mutating past parameters. Passing a boolean into a function is a terrible practice because it proves the function does more than one thing. In this class, the public static render method must accept an isSuite flag for backward compatibility with external callers. But watch how actively Uncle Bob solves this problem. The very first line of the private render function saves that flag into a instance field. This is suite equals is suite. By borrowing the flag immediately, every other private method in the class remains completely nihilistic and free of Boolean logic. Side effects are lies that break developer trust. Look at the beta examples on your screen. If isTestPage secretly cleared our buffer using setLength 0 here, it would force a dangerous temporal coupling, but in our real code, every function is perfectly honest. Also, notice the error handling style. There is not single ugly try cache block pollution or business logic. Instead of using dirty error code enums, which acts as a dependency magnet, every method simply declares throws exception, pushing error processing up to a higher architectural level. And that brings us to the absolute completion of chapter 3. By looking at SetupTeardownIncluder.java, we can clearly see that clean programming is actually the art of clear language design. Master software engineers don't just write instruction for machines, they design domain-specific language to tell clear stories to other humans. Now that we have completely mastered how to write clean, confused functions, we are ready to move on to our next major topic. In our next video, we will start chapter 4 comments and explore why clean code shouldn't need comments to explain itself. Thank you so much for watching this summary. Make sure to hit that subscribe button, and as always, stay professional.